Hi all again. Today, inshallah, we'll talk about functions, but this time, rather than solving questions, I'll explain a little more about functions and how can I solve questions involving functions in M1 exam. Then I will do like 1 or 2 questions, maybe 3 questions. So, inshallah, let's start. So the first thing, you need to know how to distinguish between the functions and the relations, okay? All relations, such as an example like y equal x, y equal x squared, okay, x squared plus y squared is equal to r squared. So first of all, remember, the function can be determined from the relation if the x, which is the input, like 2x or maybe 2 input can give me y, this is accepted as a function, and 1x can give me only one value, like one domain, one range, this is accepted to be a function. But the case which is not accepted, 1x will give me 2y, 2 output, this is not considered as a function. As an example, okay, if you can see here the circle, okay, so let's go deep. Let's say x is equal 1, so x is going to give me this point and this point, check y and this y. So since one value of x give me 2 values of y, in this case this is not a function. Okay, is there another way just to determine that if it's a function or not? Yes, there is a vertical line test. Let's check this, a vertical line test. We're going to make cross, okay, if it cuts the curve by 2 points, so we say that it's not a function. As an example, okay, if we look for the parabola in the quadratic function, which is this way, okay, so this is the parabola, okay, so y equal x squared in this case. So check this, if I do a vertical line test, whenever I cut the parabola, it's only 1 point, 1 point, 1 point, 1 point, 1 point. Since it's a 1 point, this is considered as what? A function, okay? So generally, okay, functions, okay, there are many functions, but remember, there are certain rules to consider this is a function or not. Do vertical line test, and remember that, okay, for the function, you need to test that the input and the output relationship between them. You can decide after that which one is a function and which one is originally a relation, okay? So see in question 1, let's go. Okay. Okay, here we go. So these are the three functions, okay, we call it the parent function. This is the linear. Whenever I have x, I have y, xy, xy. So if 1x, the y1, 2x, the y2, okay? So and here, the parabola, the quadratic functions, 1 give me 1, 2 give me 4, negative 2 give me 4 also, okay? And here the cubic function, okay, also has the input-output. But we need to determine something here, which is really important, the domain and range. So what's the domain and range of the linear function? If you can see, I can plug in all the inputs that I can, it's possible for me. So here I call the domain, so that's going to be x belongs to a real number and range y belongs to a real number, because I can see that, okay, all the inputs generate an output which is similar, 1, 1, 2, 2, 3, 3, so then I can plug whatever I want from the x, and at the end the y will give me the same input, which is the range. But in the case of y equal x squared, look at this, okay, the graph is already limited in the positive y-axis. So can check here, if I put 1, the answer is 1. If I put 2, the answer is 4. Put negative 1, the answer is 1. If I put negative 2, the answer is what? Also 4. Okay, so in this case, my domain, x belongs to a real number, but the range is y greater than or equal to 0, because it's above the x-axis. So that's the reason why I call this, it's limited in the positive y-axis. But the x cube here, as you can see, domain x belongs to a real number and the range y belongs to a real number. I don't have any issues with the, okay, cubic functions. So these are the 3 parts of the parent function, which is the x squared and x cube. Let's check another parent function. Wait me like a few seconds. Here we go. These 2 functions, okay, in M1 we just talk about them, and in M2, of course, we're going to explain more deeper, okay, in the characteristics of these 2 functions. But the one on the left, here it is what? The square root of x. Of course, what's inside the x, it should be greater than or equal 0. So the domain here, x should be greater than or equal 0. And we can see also the y, okay, in this case, so the y range, y greater than or equal 0. Because we can see it's the positive x-axis and positive y-axis. In this case, this is a rational function, which is what? 1 over x. Of course, I have the domain. Here, x belongs to domain. X belongs to all real number, but x cannot be 0, because in the 0, it is going to be infinity. We call it the vertical asymptote. Of course, we're going to understand that in the future classes. And we have also here the horizontal asymptote, which is y equals 0 also. So the range y belongs to all real number, y belongs to all real number. At the same time, y does not equal to 0. So I should be careful in the y part, because that also doesn't equal to 0. So in this case, my range and domain also limited, okay? That I can include all the x, the input, okay, all real numbers in the domain and in the range, but be careful. I need to exclude the x equal to 0, which is the vertical asymptote, and y equals 0, which is the horizontal asymptote. Fine, let's go for other questions and check next. Okay, this is one type of the questions which can like understand the introduction of the functions and how can I determine the changes of this function based on transformation. So transformation, always remember. So f of x equals x squared, this is my parent function. If I say plus k, means I'm going to shift it up, okay? And if I say minus k, I'm going to shift it down, okay? And if the function is being this way, x minus k inside means shift right by k units, and if the function is x plus k squared means shift left by k units, okay? So those are the translation part, which is shift up, down, right, left. Of course, this is going to be basic one in the M1. In M2, I'm going to explain it in more details. So now this is the shifting part. For the reflection, if it has a negative sign outside, so this is a reflection across what x-axis, up, down, that will affect, of course, the domain and range. Fine. And if the negative x is inside, this is reflection across y-axis, this is not going to affect in the quadratic function, because this is an even function and it's symmetric about y-axis. So in this case, this will not do any effect on the parabola, but just generally, if the negative you find it inside with x, you say that the reflection across y-axis. So this is regarding the reflection. We talked about translation, this is reflection. The thing is now left with the horizontal, vertical stretch and compression. If the x is multiplied, let's say ax squared, this is vertical stretch, and a should be greater than 1. And if a is less than 1, greater than 0, I mean like a fraction, we say this is a vertical compression. So if a is greater than 1, a greater than 1, you say, a greater than 1 means this vertical stretch. And if a is less than 1, greater than 0, I mean this as fraction, we say that vertical compression. Here comes the challenge now about horizontal part, which is if it's 1 over b x all squared. If b is a whole number, which is greater than 1, we say this is a horizontal stretch. But if b in this case, less than 1, greater than 0, we say that this one is what? A horizontal compression by a factor of what? 1 over b. Okay, so those are the major transformation. You can apply them in the functions and be always careful using them, because it's going to affect the domain range. Let me give you an example so you can understand me now. So in this case here, if I want to do it like -2 as an example, so generally, okay, the parabola is going to be the parabola, okay, the original parabola, which is touch the x-axis, but since I shifted it 2 units down, that's going to be this way. Okay, not exactly, so this is going to be in the -2. So the black one, domain, x belongs to all real number, and the range, y greater than or equal 0. The change happened now because it shifted 2 units down. The domain remains as it is, but the range is going to be y greater than or equal to what? -2. So the domain, that's going to be the same, but in the same time the range, y greater than or equal what? -2. So be careful. Transformations, you need to try all the transformation and check. Use the quadratic function, which is x squared, the parent one, and try all the transformations so you can understand how the effect going to be on the domain and range. Okay, let's go for the second part, okay, which is the inverse of the function, and we will end up by composite functions. Okay, this is a small brief about how you can get the inverse. Of course, the inverse, just like a brief, what is the inverse? How can I get the inverse? In M2, we'll explain the graph. So this is y equal x, as you can see here. So whenever, like I say, a shape like this, I'm having, and above the y equal x, let's say this is the shape, this way. So the reflection across y equal x, that's going to be this way. So this is what I call the main function, and this one I call it what? The inverse of that function. But how can I get it algebra way? Check this with me. As an example, f of x equals x plus 7. Okay? Let's say x plus 7. So let's go y equal x plus 7. Then you change the alphabets. Going to be x is equal y plus 7. Okay? Then after that, we put y as a subject. So y is equal x minus 7. And here we go. So f inverse, I call this f inverse. That's going to be x minus 7. And how? This is the inverse of the function what? Which is x plus 7. Okay, also train your hand on the inverse function so you can understand how it works out. Okay, fine. The last thing, FOG, GOF, we put okay functions inside each other and we can check how questions comes like that. Check this out. Okay, composition of functions. When you say composition of functions, just like you can say that you plug g of x inside f of x and f of x inside g of x. And how that is going to be written? This is f of x equal x squared and g of x is equal x plus 1. If I say FOG of x, it means that I'm going to put the g function inside me f, right? And GOF of x, I will put f function inside what? G of x. So in this case, in the first one, g, which is the x plus 1 inside of x, that's going to be, you leave here bracket and you just plug this inside. So x plus 1 all squared. So just like you put it inside that function. And the other hand, okay, which is GOF, I'm going to put x squared inside what? X here is going to be x squared plus 1. Okay, so in these two cases, we just made FOG of x and GOF of x means inside each other. And remember always, okay, there's a certain trick, okay, we need to understand. If I put FOG and I get x, as an example, another way, FOG, and I got also g of f of x at the end, it got mean x. Means in this case, f of x is inverse of g of x. If I get both two x's, okay, so f is inverse of g and g is inverse of x. Fine. The functions is like, has many, this topic has many things to do, okay, practice, involving operation with functions, adding up, subtract, multiply, composition of functions, inverse, domain, range, graphs, okay. So it's like a lot of things. If you find anything, any comments and anything related to this topic and you want from me to explain it in my YouTube channel, you be my guest, okay. And here we go, see you in the next video. Bye bye.